Fine. So once again, a very good afternoon to all of you. So today we are going to look into the GOC and hydrocarbons lessons problem solving. Okay, general organic chemistry and hydrocarbons lessons problem solving. So the topics that we are going to cover in today's session are the nomenclature, isomerism, reagents in organic chemistry, electronic displacement effects, and hybridization. Okay. So from these topics only, I have selected few questions for today's session. And let's try to solve all the questions, okay, within the half an hour which we are having today. Okay. So let's do it together. So let me go for question number 1. The correct stability order of the following resonance structure of the given compound is, there are three structures given for the compound. We have to find out the correct stability order. So how to find out the correct stability order for this? So now if you want to find out the stability order, first of all, you need to know the points that you have to follow or the important things that you have to follow to find out the more stable resonance structure. Okay. So I will give you those points now. The very first point is the neutral molecule or the non-polar molecule will be highly stable. Okay. The non-polar molecule will be highly stable. So non-polar means there will be no plus minus charge separation in the compound. Okay. So among these three compounds, the first compound and the second compound has the positive and negative charge, right? Charge separation is there. Whereas in the third compound, we don't have any charge separation. So it is non-polar in nature. So it will be highly stable. Okay, it will be more stable. And next, what you have to do? So the next you have to go for the other two structures. So among these three, the third one is highly stable. Only in one option we have compound 3 as the more stable part in the option, which is option C. So that is the correct answer for this question. But let me give you the reason for the other two also. Okay. So from structure 1 and structure 2, if you see, charge separation is there. But yeah, the charge separation is there. But the negative charge should be localized on the more electronegative atom. The negative charge should be on the more electronegative atom. Only then that structure is said to be more stable. Okay. So if you follow this rule and if you see to the compounds, the first compound is having the positive charge on oxygen. Oxygen is the more electronegative atom. And in the second compound, we have negative charge on the more electronegative oxygen. Okay, so which one will be more stable? The second compound is more stable compared to the first. Okay, so what are the 2 points you have to keep in mind? The first point is the non-polar compound will be highly stable. Okay, then for the polar compounds which are having charge separations, the negative charge should be on the more electronegative atom. Okay, only then the compound will be stable. Got it? So you can use these 2 points to find out the stability of the resonance structure. Got it? Is it clear to all of you? Shall I go for the second question? Do you have any doubts from the first? Shall I move on to the second question? Praveen, Rohit, students, can you able to follow? Janvi, Dahod, can you able to follow? Shall we go for the next? Say yes or no in the chat box. Yes. All right. So the next question is here. The IUPAC name of the following hydrocarbon is. So this is a question from nomenclature, right? So very easy. So we have an alkane here. Okay, we have an alkane where there is only carbon-carbon single bond. We have to find out the IUPAC name of this compound. So to find out the IUPAC name, okay, what is the first rule that we have to follow? Firstly, we have to find out the longest chain. First, we have to find out the longest carbon containing chain, right? Which is a straight chain here in this case. Then what we have to do, we have to start numbering. We have to start numbering the carbon atoms. Now, how will you number? From left to right or from right to left? From left to right or from right to left? Which one is correct? Can anyone find out the name or the way of numbering for this compound? Left to right numbering is correct. Okay. So 1, 2, 3, 4, 5, 6, 7, and 8. Got it? So this is how we have to number. Now there are 3 substituents attached and all the 3 substituents are same. Okay. 2, 5, and 6. So to the second carbon, to the fifth carbon, and to the sixth carbon, we have methyl groups. Okay. So the answer will be 2, 5, 6 trimethyl octane. Okay, 2, 5, 6 trimethyl octane. Okay, so this is the correct answer for this question. If you have more than one substituent, same substituent means, then you have to use the word tri. Okay, and we have 8 carbons in the parent chain. So I have used the root word oct. Got it? Since it is an alkane, the suffix is ane. Clear? Now let's go for the third question. Which of the following are aromatic? Which of the following are aromatic? So if a compound has to be aromatic in nature, it has to follow 4 rules, right? So what is rule number 1? For a compound to be aromatic, it should be cyclic. It should be cyclic, okay? And secondly, the system should have sp2 hybridization, okay? All the atoms in that cycle should have sp2 hybridization. Okay, sp2 hybridization means the structure should be planar. The structure should be planar. Got it? And thirdly, there should be complete conjugation or complete delocalization of electrons. Complete delocalization of electrons should be there. Delocalization of pi electrons. Delocalization of pi electrons should be there. And finally, it should follow Huckel's rule. So what is Huckel's rule? Huckel's rule means 4n plus 2 pi electrons should be there. 4n plus 2 pi electrons should be followed. So you have to use these 4 rules to find out the answer. Okay. So if you go for compound A is cyclic, but if you look into the hybridization, this particular carbon, it is having only single bond around it. If it is having only single bond around it, then the hybridization of this carbon is sp3, right? sp3. sp3 means it is tetrahedral. It is not trigonal planar. It is tetrahedral. Got it? So option A, compound A is not aromatic. It is not following rule number 2. Okay. Then if you go for B, compound B is cyclic in nature. It is cyclic in nature and this is the substituent. This is the substituent. Now, all the atoms which is forming this ring, they are sp2 hybridized because all of them are double bonded carbon. Okay, so they are planar. And also there is delocalization of electrons. There is delocalization of electrons here. Let me erase this. Okay, delocalization of pi electron is also possible. It is looking like a benzene, right? And also since we have 3 pi bonds, there are 6 pi electrons, which follows Huckel's rule. If n is equal to 1, then we will have 4 into 1 plus 2 as 6 electrons, right? So 6 pi electron means it is following the Huckel's rule also. So compound B is aromatic in nature. Okay. Then if you go for compound C is cyclic. All the carbon atoms are sp2, so it is looking like a planar. Okay. But if you go for the hydrogens which are attached here and here we have an hydrogen, right? So those 2 hydrogens, they are not on the plane. They are out of the plane. Okay, the compound is not planar, it is non-planar. Compound is non-planar because of these 2 hydrogens interaction. Okay, so it fails to follow rule number 2. So compound C is also not aromatic. Okay, then coming to compound D. Compound D is cyclic and all the carbon atoms are sp2 hybridized and there is complete delocalization of pi electrons. Okay. So if you delocalize the electrons like this, you have complete delocalization of pi electrons. And how many pi bonds we have here in this molecule? We have 1, 2, 3, 4, 5, 6, 7 pi bonds. 7 pi bonds means if n is equal to, if n is equal to 3, in 4n plus 2 rule, 4n plus 2 pi electron Huckel's rule, if you substitute n is equal to 3, so you will have 14 electrons. If n is equal to 3, we will get 14 electrons, right? So there are 7 bonds here and 14 electrons. And if I substitute n as 3, I'm getting 14 electrons, which is obeying the Huckel's rule also. So compound B and compound D are aromatic, whereas compound A and compound C are not aromatic in nature due to the reason that I have mentioned. Okay. So option A is the correct answer for this question. Option A is the correct answer for this question. So can you able to understand? Can you able to understand, students? Do you have any doubts here in this question? Shall I go for the next? Shall I go for the next? Just let me know the answer fast. Say yes or no. If you have any doubt, please let me know. So what are the 4 rules? It should be cyclic, should be planar, should have complete delocalization of pi electrons, and finally, it should follow Huckel's rule. Okay, so these are the 4 criteria for a compound to be aromatic in nature. All right. Now let me go for the next. Given below are 2 statements. Given below are 2 statements. In both the statement, the IUPAC name of the given compound is written. Okay. Now we have to find out the most appropriate answer from the options given below. So let's check whether the IUPAC nomenclature is correct for both the compounds. Let's go for statement 1. If you go for statement 1, the name is given as 4-chloro-1,3-dinitrobenzene. Is it right? It is not correct. Okay, it is not correct. Let me draw the compound like this for your better understanding. So the compound is like this, Cl, and next to Cl we have NO2. Then to the alternative position of this NO2, we have another NO2. Okay, so I can write this compound like this. Now I have to start numbering, right? The numbering has to be given following the Locentz rule. So what is Locentz rule? The substituent attached carbon should get the lowest number. If we have 3 substituents, if we want to get the lowest possible number, then I have to start numbering from this chlorine. 1, 2, 3, 4, 5 and 6. Okay. If you go for any other way of numbering, like for example, if you're starting from this particular NO2, 1, 2, 3, 4, 5 and 6, then you will end up with 1, 3 and 6. Okay, 1, 3 and 6. But in the first numbering that I have done, it is 1, 2 and 4. 1, 2 and 4, right? So if you add this, what you will get? You will get 10 here. And here we will get 7. So 7 is the lowest number. So this is the correct way of numbering. If you are getting 10, it is highest. So it is incorrect way of numbering. Okay. So the numbering has to be done in such a way that the substituents attached to carbon should get the least possible number. Okay. So this is the correct way of numbering. Starting from chlorine and going in a clockwise direction is the correct way of numbering. Okay. So now what is the name of these substituents? This is called as chloro. And these two are nitro. So according to the alphabetical order, C comes first, right? So the name of this compound is 1-chloro, 2,4 dinitro, 2,4 dinitrobenzene. Clear? 2,4 dinitrobenzene is the name of the compound. But here the numbering is wrong. So statement 1 is incorrect. Okay. Then coming to statement 2, we have again we have 3 substituents. So I have to start from here. 1, 2, 3, 4, 5, and 6. So 1 is called as amyl, 2 is methyl, 4 is ethyl. Okay, C2H5 is ethyl. According to the alphabetical order, E comes first. So 4 ethyl, 2 methyl, and this part is taken as aniline. If NH2 is attached to the benzene ring, it is called as aniline, right? So it is aniline. 4 ethyl, 2 methyl, aniline. So it is correct. So statement 1 is incorrect, but statement 2 is correct. So option D is the correct answer for this question. Okay. So is it clear to all of you? JNV Kodagu, JNV KSD, JNV Anam. Can you able to understand this? Shall we go for the next question? Shall we go for the next question? Do anybody have any doubt here? Okay. Now going ahead with the next question. The incorrect statement regarding ethine is. So what is ethine? C2H2 is called as ethine. Okay. C, triple bond C and H attached compound is called as ethine. Okay. So now let's check with the options. Let's check with the options. So option A says that carbon-carbon bonds in ethine is weaker than that in ethene. So what is ethene? Ethene is C2H4. C2H4 means C double bond C, and there are 4 hydrogens attached to this double bonded carbon. Okay. The carbon-carbon bond in ethine. This is carbon-carbon bond in ethine. This is carbon-carbon bond in ethene. So this is a triple bond and this is a double bond. Triple bond is stronger compared to double bond. Okay. So triple bonds are stronger compared to double bond. Double bond is weaker. Okay. There are 3 bonds and here we have only 2 bonds, right? So if you compare triple bond and double bond, triple bond will be stronger. Triple bond will be stronger. It means ethine has stronger bond than ethene. But here the statement is incorrect. They have said that ethine is weaker, having weaker bond than ethene. So that is the incorrect statement, which is the correct answer for this question. Okay. All other options are correct. Let's check. Both carbons are sp hybridized in ethane. Yeah, it is sp hybridized because both of them are triple bonded, right? Triple bonded means hybridization will be sp. Double bonded means it is sp2. So triple bond means it is sp. And CC bonds in ethine is shorter than ethene, obviously. So if the number of bond increases, bond length decreases. If the number of bonds increases, the bond length decreases. So here we have 3 bonds and here we have 2 bonds. If the number of bonds increases, the bond length decreases. So it will be very short. Carbon-carbon triple bond will be short. Okay, so that is correct. And ethine is linear. It is having a linear structure, right? With 180-degree angle with each other. It is linear. So the only incorrect statement about ethine is option A. Okay. Shall we go for the next? Shall we go for the next? Shall we go for the next question? Okay, fine. In the given compound, the number of secondary carbon atom is. There are different types of carbon atoms, right? If a carbon is attached to only one carbon, then it is said to be a primary carbon. If a carbon is attached to 2 carbon, then it is a secondary carbon. If a carbon is attached to 3 carbon, then it is a tertiary carbon. Okay, if a carbon is attached to 4 carbon, then it is a quaternary carbon, right? Now we have to find out the number of secondary carbon atoms in this compound. So let me expand this structure for your convenience. Okay, so I have CH3. Then what we have carbon, hydrogen, and To this carbon, one more CH3 is attached. This one. Okay. And this carbon is attached with CH, H. And again here it is attached with H and CH3. And one more CH3 is at the right side. Got it? So these two CH3s are at the top here. Okay. So this is the expanded structure. Now let us start from the first carbon. Let us take this carbon. So this carbon is attached with only one carbon, right? You cannot think like hydrogen is attached to the carbon. Okay, it means the carbon is attached to the carbon. So this carbon is attached to only one carbon. So it is a primary carbon. Okay. And if I go for second carbon, it is attached with 1, 1, 2 and 3. So it is attached with 3 carbon. So it is a tertiary carbon. It is a tertiary carbon. Now if I go for the central carbon, this one, it is attached with 2 carbon, one in the left side and the other one in the right side. So since this is attached with 2 carbon, it is called as secondary carbon. It is called as secondary carbon. And then if you come to the fourth carbon, it is attached to 3 carbon, one above and one left and one right. So it is attached to 3 carbon, so it is tertiary. And all the terminal carbons are primary because they are attached to only one carbon. Okay. Now you tell me how many secondary carbon atoms are here in this molecule? Only one. Only this carbon is a secondary carbon, whereas 4 of them are primary and 2 are tertiary. Clear? So option D is the correct answer for this question. Okay? Clear? I hope it is clear. So this is a question from the types of carbon atoms. Okay. So now let's go for one more question from nomenclature topic. So we have got a structure. Okay, I will write the structure like this. For your convenience, I will write a structure like this. The fluorine, NO2, and alternative to NO2, we have C2H5. Okay. So how we have to start numbering? We have to start from fluorine. 1, 2, 3, 4, 5, and 6. Okay. So F means it is called as fluoro. NO2 is called as nitro. And C2H5 is called as ethyl. According to the alphabetical order, E comes first. So 4 ethyl, 1 fluoro, 2 nitro, benzene. Okay. 4 ethyl, 1 fluoro, 2 nitrobenzene. Option A is the correct answer for this question. 4 ethyl, 1 fluoro, 2 nitrobenzene. Clear? Is it clear to all of you? If any structure is given to you like this with the tri-substituted thing, you just tilt the compound and write like this and start naming. That's it. Let me go for the next question from NEET 2024. So we have 2 statements. Okay, statement 1 says the boiling point of 3 isomeric pentanes follows the order. So 3 types of pentanes orders are given. So N-pentane, isopentane and neopentane. So what is N-pentane? Normal pentane. All the 5 carbon atoms are arranged in a straight chain like this. So it is called as N-pentane. And isopentane means there will be one branch. Okay, 4 carbon atoms will be there on the chain and one is branched. And neopentane means 3 carbon atoms will be there on the line. Okay, 2 carbon atoms are branched. 2 carbon atoms are branched. Okay, so these are the structures. Now we have to go for the boiling point. Since all the 3 compounds are having the same molecular formula but different structure, you have to use the relation which is boiling point inversely proportional to branching. Okay, if the molecular masses are same, then you have to follow this order, this relation. Boiling point is inversely proportional to branching relation. Okay. So the one which is having the least number of branches will have the highest boiling point. That is the meaning. Okay. So in case of first compound, we don't have any branch. So that will have the highest boiling point. Then when you compare second and third, Isopentane and neopentane. Isopentane is having only one branch, whereas neopentane is having two branch. Okay, so isopentane will have the highest boiling point. So this is the order given in statement 1 also. So statement 1 is correct. Statement 1 is correct. Now let's go for statement 2. When branching increases, the molecule attains a shape of a sphere. Is correct, right? When branching increases, that is for third compound, you see the molecule is attaining the shape of a sphere. Okay, it is spherical in shape. So this results in the smaller surface area for contact. It is also correct. So here the surface area is very high, but here the surface area is very less, due to which the intermolecular forces between the spherical molecules are weak. Intermolecular forces means the force which is acting between two molecules. So that will become weak and the boiling point will become less. If the forces are weak, the molecule can easily boil. Okay, the interactions will be broken down easily if the forces are weak. So the boiling point will be very less. So the given statement 2 is the correct explanation for statement 1. Okay, both the statements are correct. Both the statements are correct. Both statement 1 and statement 2 are correct. Okay. So I hope it is clear to all of you. There are two relations you have to follow. Okay. One is this and the other one is boiling point directly proportional to molecular mass. This is the second relation. So you have to use this first relation if the molecular masses are same. That is for isomers, you have to use this relation. And the second relation you will be using if the molecular masses are different. Okay. If the molecular masses are different, then you have to use the second relation, where the boiling point is directly proportional to molecular mass. The compound which is having the highest molecular mass will have the highest boiling point value. Okay. These are the two things you have to keep in mind. This is the concept. Whatever might be the question given to you, you have to apply this concept only. Okay. Now let me go for one more question. The compound with a molecular formula of C6H14 has two tertiary carbon. Its IUPAC name is two tertiary carbon. Okay, again, this is a question from different types of carbon. So to answer this question, let me draw the complete structure of all the four molecules given in four options. So one is, in option A, it is N-hexane. N-hexane, normal hexane. Hex means 6 carbons, right? So let me write all the 6 carbon in a straight chain fashion like this. Okay. So now here if you see, the first carbon is attached with only one carbon. So it is a primary carbon. And the second carbon is attached with two carbon, left and right. So it is a secondary carbon. Again, this is also secondary. Fourth carbon is also secondary. Fifth carbon is also secondary. And the sixth carbon is primary. We don't have tertiary carbons in this option A. Okay, so it cannot be the answer. Then let's go for option B. 2-methyl pentane. So let me write pent first, which is a 5 carbon containing chain. And to the second carbon, there is a methyl group, CH3 group. Okay. So here it is attached to only one carbon. The first carbon is primary. Second carbon is attached with 3 carbons. So it is tertiary. Again, this is primary. Third carbon is attached with 2 carbons. So it is secondary. Again, secondary. And this is primary. So we have only one tertiary carbon in this compound. So option B is also incorrect. Okay. Then coming to option C. 2,3-dimethyl-butane. So but means 4 carbon. And to the second carbon and the third carbon, we have a methyl group, CH3. Okay. So if I go for first carbon, it is attached to only one carbon. So it is primary. And if I go for second carbon, it is attached with 3 carbon, left, right, and below, bottom. Okay. So it is a tertiary carbon. And this one also, it is attached with the 3 carbons. So tertiary. Here it is only one, primary, primary, and primary. So in this compound, we have 2 tertiary carbons. Okay. So option C is the correct answer for this question. You can check with option D also. 2,2-dimethyl butane. This is butane. To the second carbon itself, we have both the methyl groups attached. Okay. So all the terminal end carbons are primary. So all these are primary carbon. And if you go for the second carbon, it is attached with 4 carbons. So it is a quaternary carbon. And the third carbon, this one is attached with 2 carbon, which is a secondary carbon. We don't have tertiary carbon in option D. So it is also incorrect. Okay. So option C is the correct answer for this question. Okay. Now let's go for one more last question for today's session, which is, which among the following compounds will show geometrical isomerism? So this is a question from isomerism topic. There are 2 types of isomerism, right? Structural isomerism and stereoisomerism. Under the stereoisomerism, we have 2 types. One is geometrical isomerism and the other one is optical isomerism. So this is a question from geometrical isomerism. The other name for geometrical isomerism is cis-trans isomerism. Okay, it is called as cis-trans isomerism. You know what is cis and what is trans, right? If 2 similar groups are attached to the same side of the double bond, it is cis. If they are attached on the opposite side of the double bond, it is trans. This is the concept. Now let us try. Let us check for all the compounds in the options. So first one is pent-1-ene. Pent means 5 carbon. And between carbon number 1 and 2, we have a double bond. Okay, this is pent-1-ene. Now the remaining things are hydrogen. Hydrogen here, and here we have 1 hydrogen. Okay, here CH2, CH2 and CH3. So this is a double bonded carbon, and here we have 3 hydrogens attached. At least 2 groups should be different. At least 2 groups should be different. Then only that particular compound will show the geometrical isomerism. Here 3 of them are same. 3 of them are same. Okay, so it will not show the geometrical isomerism at all. So pent-1-ene cannot be the answer for this question. Then coming to option B, we have 2,3-dimethyl-bute-2-ene. This is bute. Carbon number 2 and 3 have a double bond, and 2,3-dimethyl. So this is a double bonded carbon, and to this double bonded carbon, we have 4 methyl groups attached. 4 compounds are same. Okay, again, it will not show geometrical isomerism. If I go for the option C, prop means 3 carbon. This is 1 ene and 2 methyl. Okay, so this is a double bonded carbon. We have 2 hydrogens here. We have 2 hydrogens to the first carbon and 2 methyl groups to the second carbon. Got it? 2 of them are different, but the similar atoms or groups are attached to the same carbon. Okay, so again, it cannot be the answer. If I go for option D, hex, right? 1, 2, 3, 4, 5, 6. 3 means between third carbon and fourth carbon, we have a double bond. And 3,4 dimethyl. 3,4 dimethyl. So this is the double bond. Here we have 2 carbon system, which is ethyl, and here 1 carbon, which is methyl. And to the second double bonded carbon also, we have 1 ethyl groups attached and 1 methyl group attached. Got it? So 2 similar groups are present on the same side that will show cis, and if they are present on the opposite side, they will show trans. Okay? So 2 groups are present. Okay? 2 groups are different, and 2 similar groups are present on both the double bonded carbons. So option D will show the geometrical isomerism. Option D will show the geometrical isomerism. Is it clear to all of you? Can you able to understand? Can you able to understand? So in option 3, we have 2 similar groups, but 2 similar groups are attached to the same carbon. But here, if you take this carbon, we have different groups attached, 1 ethyl and 1 methyl. So it should be like this. Then only the compound will show geometrical isomerism. Okay. So this is enough for today. You have your next class right now, right? So you can get ready for the class. And in the next session, we can meet up with the next set of questions. All right. Do you have any doubts from today's session? Is everything clear for all of you? I have got some more questions also, but since due to the technical issues arised in the beginning of this class, we could not able to cover most of the questions, but no problem. We will try to cover it in the next session. Okay. So thank you so much, students, for attending the chemistry class today. See you all in the next class. Till then, take care. Bye-bye.